So welcome to video course tutorial on signals and systems subject. So if time shifting is performed after time scaling, then the original shift amount must be divided by its scaling factor. This is what is covered in previous video. Say if you take k common here, you are going to get t plus or minus t naught by k. That is, now the new shift has to be performed by original shift factor t naught divided by k. If x of t has area called a variable area, then minus a into x of minus kt plus or minus t naught has the area minus a by k into this earlier area. If you see this signal, observe my mouse pointer carefully. Amplitude inversion, amplitude scaling, time inversion, time scaling, time shifting. 5 different operations are performed on the same signal x of t. I already told you amplitude inversion changes the area by same factor, hence minus comes here. Amplitude scaling changes the amplitude by the same factor, hence a comes here. Time scaling also changes the area with same factor but in the denominator, that is x of kt means time axis is divided by k, time variables are divided by k, time width is divided by k, area is divided by k. Time inversion and time shifting have no effect on the area. So please follow these examples, do them one by one carefully. If you given that area of x of t is 5, then area of minus 2 into x of 3t minus 5 is minus 2 amplitude scaling plus amplitude inversion as it is they appear. So minus 2 factor is as in the output. Time scaling by 3, area is divided by 3 into original area minus 10 by 3. Area of minus 2 into x of minus 3t. So minus 2 into time inversion has no effect on area. So only time scaling with 3 should be considered. So area is divided by 3 into 5 minus 10 by 3. Area of minus 2 into x of minus 3t minus 5. So this factor comes as it is. Time shifting has no effect on area. Time inversion has no effect on area. So area is divided by 3 here. Your answer is minus 10 by 3. Waveform of x of t is given. Construct waveforms for the following functions. Say x of t area is this. So if you need mathematical definition for this sequence, means for minus 2 less than t less than 0, amplitude is minus 3. For 0 to 3, it is a ramp function with equation as y by x, that is slope times of the x-axis variable. To get the slope, you need to use dy by dx y2 minus y1 by x2 minus y1. So if you consider this point, its coordinates are 3, 4. If you consider this point, its coordinates are 0, 0. So slope means change in y, this change by change in x, that is this change, that is plus 4 by 3. So this line equation will be plus 4 by 3t. So for 0 less than t less than 3, x of t is equal to 4 by 3t. For 3 less than t less than 5, x of t is equal to 4. Now equation of slope. So if you see y is equal to mx means y-axis is a function of x-axis variable. Here x of t is a function of t variable x of t. Y is equal to mx. Variable in x-axis is t here. Function of y-axis is represented here as x of t. So you are going to write x of t is equal to 4 by 3t. This is what is stated now. X of t is equal to minus 3 for minus 2 to 0 range, 4 by 3t from 0 to 3 range, and 4 from 3 to 5 range, and 0 elsewhere. Elsewhere means t less than minus 2 and t greater than 5 in these ranges. Now x of 2t plus 3. So first question is, he has given x of t range is minus 2 to 5. He is asking you to find the range of x of 2t plus 3. First method is replace t by 2t plus 3. Why we are replacing t by 2t plus 3? We know x of t given in the question. This is t range is minus 2 to 5. We want to know the x of 2t plus 3 range. So in place of t, earlier question is x of t, now given x of 2t plus 3. In place of t, in the question given x of 2t plus 3. T is replaced by 2t plus 3 in x function. So replace t by 2t plus 3 in the mathematical definition also. So x of t is equal to minus 3 minus 2 less than t less than 0, 4 by 3 into t to 0 less than t less than 3, like that is their equation earlier. So now we are just replacing the t by 2t plus 3 in this mathematical equation. Here t is there, here t is there, here, replace t by 2t plus 3. So we are going to get in this form. Now we just simplify, that is minus 3 less than minus 3 is the amplitude in the time range, minus 2 less than 2t plus 3 less than 0 means minus 3. Time range will now become, we need to do minus 2 minus 3, that is minus 5, and you, so what you do is for this equation you subtract by minus 3 on both sides, then in the middle you are going to get only 2t. Next you divide by 2 on all three sides, then you are going to get t here. Our aim is to get t in the middle, minus 2.5 less than t less than minus 1.5. So this is the new range. Now you, based on this, you draw. So in the minus 2.5 to minus 1.5, draw a straight line with amplitude minus 3. Why it is a straight line? If you see here, it is minus 3 into t power 0, minus 3 into 1, minus 3, t power, since t power 0 is 1. So if you see, it is t power 0, that is slope is 0. If you see here, it is 4 by 3 into 2t plus 3, t power 1, that is slope is 1. Okay, so this is how you need to know it. Now as here slope is 1, that is it should be a ramp signal with positive slope as 2 into 4 by 3, and it is a straight line not passing through origin. If it is passing through origin, then its form is y is equal to mx, some k times of t, but here k in times of t plus some constant is there, that is it is in the slope intercept form, that is y is equal to mx plus c. To find the points of intersection with the t axis, substitute y equal to 0, or to find the point of intersection with the y axis, substitute x or t equal to 0. So I have to substitute t equal to 0, I am going to get 4. So this is the intersection with y axis. If I want to know the intersection with x axis, substitute x of t equal to 0, that is for 2t plus 3 equal to 0, 2t equal to minus 3, t is equal to minus 1.5. Okay, now amplitude is 4, it is a straight line, constant, 0 slope. Why? Because into t power 0 is there. Nothing is there means into t power 0. You say it is 2, the factor is 2t square, then slope is 2, means it is a parabola. At that time you cannot really use y is equal to mx notation. You need to use y square is equal to 4ax notation. So 0 for t elsewhere means after t is equal to 1, to the right side of t equal to 1, that is t greater than 1. So if method 2, so method 2 is, I told you there are two methods in the argument, either you follow left to right or right to left. I told method 1 we will follow, that is right to left in my previous video. So first if you move from right to left inside this argument, so x, this C type brackets are there, whatever is there inside that is called argument. So in that argument, while reading you read as 2t plus 3 is the argument, means whatever is there inside x function. So now we will follow right to left, that is when you are reading from right to left, plus 3 is encountered first, that is time shift. So replace t by t plus 3, that is same sign, that is shift left, that is time shift, left shift by 3 units, x of t plus 3. So you shift x of t by 3 units to the left and draw and rename it as some another signal y of t. Now you are reading like this, t plus 3 is completed. Now see, right to left you are proceeding, first you encountered 3, it is a t naught factor, shift variable value, keep it aside, plus that is shifting, you have done just now. Next t, that is a time variable, keep it aside, come 2t, that is at, that is x of kt fraction or x of pt, any variable, that is now time scaling. T, replace t by 2t, time scaling operation. If you try to do in the same x of t plus 3, you might arrive into confusion instead of arriving into conclusion. So do it for the y of t signal. So replace t by 2t in y of 2t, that is x of 2t plus 3, means divide time axis by 2, area is divided by 2, time width is divided by 2, all the time intervals are divided by 2, all the time variable indices are divided by 2. So this is method 3, that is left to right. First we are doing time scaling. So if you are very confident with the method 1, instead of listening to method 3, scroll the video backside and again listen to this right to left method or method 2 here. If you want to follow method 3, listen now. I prefer and advise you to follow above method, that is right to left method, that is method 2 here, or method 1 in the earlier video. X of 2t plus 3, now t is replaced by 2t, that is time scaling. Now y of t is equal to x of 2t. So here I already told you need to take 2 common, so you are going to get t plus 3 by 2. So actually you should shift by 1.5 only, so that x of 2t is shifted by 3. So you replace t by 1.5, that is time shifting. Next you need to do, you are going to get x of 2 into t plus 1.5, which is nothing but x of 2t plus 3. So same is mentioned in diagrams here. So if you see here, this is x of 2t, that is first we are doing time scaling, time axis is divided by 2, all time indices are divided by 2, that is signal is compressed as a greater than 1 and a equal to 2 here. Next we are same sign of variable t and the shift constant 1.5, so left shift by 1.5, this signal, new signal y of t, you shift left by 1.5, that is you do minus 1.5, minus 1.5, minus 1.5, minus 1.5, you add minus 1.5 to all the time variables so that the new signal will have those new time indices. Shortcut. So x of t time width means whenever it is becoming non-zero to the rightmost side, then when it is becoming 0, when it is the highest index at which it is non-zero in the rightmost side, and the highest index at which it is non-zero in the leftmost side. If you see here, rightmost side beyond t greater than 5, it is always everywhere 0 till infinite. So here also beyond t less than minus 2, it is always everywhere 0 till t is equal to minus infinite. So the time width means highest non-zero amplitude time index minus lowest non-zero amplitude occurring time index on the left side, that is 5 minus of minus 2 is 5 plus 2 is 7. So if you see here, time index is or time width is 7, but x of 2t plus 3, shifting means width is constant. Shifting means either left shift or right shift. We are holding the signal, say the graph x axis and y axis are kept constant, we are holding this figure. Assume in paint we drag the objects, Windows paint we can drag like that, we are holding this and dragging to the right side or to the left side. So shifting means width will not change, scaling means width will change. So new width is old time width by the scaling factor, so here by 2, so new width is 3.5, that you can check from here, 1.5 plus 2.5, you can get the, sorry, here it is 2.5 minus 1.5 is 1, 1 minus of minus 2.5 is 3.5, because time width is divided by the scaling factor. No, he is asking x of 2t minus 1 whole divided by 4. So method 1 is you divide individual terms, this denominator, x of 2t by 4 minus 1 by 4 is equal to x of t by 2 minus 1 by 4. Now again you can follow left to right or right to left, whichever approach you feel as convenient for yourself. First, that is another method is you can instead of directly changing from the figure, you can reverse approach from the mathematical equation. So the method one is x of 2t minus 1 by 4. If you want to find, we know t limits for x of t, that is x of t is minus 3 for minus 2 less than t less than 0. So 4 by 3 into t for 0 less than t less than 3, 4 for 3 less than t less than 5, 0 elsewhere. In place of t, substitute t by 2 minus 1 by 4. Now you do operations so that here only t remains. So first try to eliminate this term by adding 1 by 4 on all three sides. Next try to multiply by 2 so that 2 into t by 2 becomes t. Next you find the new range limits in the new equation. Based on this mathematical formula or mathematical representation, now you draw the signal. Now so this will be the x of t by 2 minus 1 by 4. If you is asking the area, you can calculate area of this rectangle, this triangle and this rectangle. So method 2 is, you are taking 1 by 2 common, that is you are following left to right approach. First you are following right to left approach. So here in the right to left approach, first you have encountered the 1 by 4 variable. If you are following left to right approach, you need to take 1 by 2 common. If you are following right to left approach, you need not take 1 by 2 common at least till this point. Why? Because first I have encountered minus 1 by 4. So time shifting by 1 by 4, x of t minus 1 by 4. Assume, give it as another name as y of t, some other signal. Now we replace t by 2, that is, this time it is x of 0.5t, a is equal to 0.5, a less than 1, time expansion, frequency compression. So first for shifting, x of t minus 1 by 4 means t is having plus sign, 1 by 4 is having minus sign, opposite sign, shift right by 1 by 4 as t not equal to 1 by 4. Next, here time expansion, each time interval value, time indices value, time axis is multiplied by 2 now, because 2 is there in the denominator. Or you can also consider as x of 0.5t, and time axis is divided by 0.5 is nothing but time axis is multiplied by 2. So minus 1.75 into 2 becomes minus 3.5, 5.25 into 2 becomes 10.5. Now you got x of t by 2 minus 1 by 4. Method 3 is left to right. So for whenever you are following left to right, you need to make something as t minus t naught fashion. So whatever is the coefficient of t, you need to take that common. 1 by 2 common, t minus 1 by 2. 1 by 2 into x of t minus 0.5. Now first you need to do the operation of x of t by 2, because you are following left to right. While going from left to right, in the argument you are first reading t by 2. So first do t by 2, that is replace t by 2, that is time scaling by 0.5. That is all the time axis indices value or time interval value or the time width you are multiplying by 2 or dividing by 0.5. Next, rename this as another signal called y of t, just for simplicity. If you have utmost confidence, you can still write it as x of t by 2, but be careful. Next you do shifting operation, y of t minus 0.5. So actual my signal x of t by 2 minus 1 by 4, that is we should shift by 0.25, but I have already multiplied by my time axis by 2. That is, now if I just shift by 0.5 only, it is equivalent to shifting by 1 by 4, because the time expansion has occurred here. As the time expansion has occurred earlier, if it is x of t, I need to shift by 0.25, but time expansion has occurred. To convey the same shifting, even my shifting value t naught should also expand by the same amount. That is the inner meaning. For every problem you need not listen all the 3 methods. First 2 methods are enough. Third method is little bit confusing if you are not having utmost clarity. So now we are doing shifting by 0.5 so that it equal to shifting by 0.25 of original signal x of t. X of t by 2 signal we are shifting by 0.5 so that it is equal to shifting x of t by 0.25. So next problem is x of 1 minus 2t. So method 1 is same. You write the x of t mathematical definition, replace t by 1 minus 2t. Now here you need to subtract by 1 on both sides. Next multiply by minus 1 on both sides. While multiplication you need to be careful. Say a less than minus t less than b. When you multiply with minus 1 you are going to get minus a greater than b greater than c. See here. Say a is less than t less than b is available. Say assume it as a less than minus t less than b. Now to get t in the middle multiply with minus 1, then it becomes minus a greater than, the symbol change you need to know, greater than minus b. So a into minus 1 is minus a, t into minus t into minus 1 is t, b into minus 1 is minus b. But you have to incorporate this symbol change also. Say for example you are multiplying with 2, then it is not required. You are dividing by 2, a by 2 less than minus t by 2 less than b by 2, then it is not required. Only for multiplying with minus 1 there is a symbol change and it is required. Why? Because say 1 less than t less than 2. So assume 1 less than minus t less than 2. Now minus 1 I am multiplying greater than t greater than minus 2. This is because whenever you are multiplying with minus 1 for the number systems inherently the property changes. This is because if you see here indeed 1 less than 2 here. So likewise if you see for this you should, the same relation should hold, minus 1 greater than minus 2. Minus 1 is greater than minus 2 because minus 1 is not less than minus 2. So this is the very intermediate concept, intermediate level concept. Okay, come back. Okay, now if you see here, now whenever you do time inversion, so the same signal what was there to the right side now becomes left side, what was there in the left side now comes to the right side, which was seen in earlier video. So positive slope becomes negative slope becomes positive slope. Why? Because say there is a signal 4 by 3 into t. Now whenever time inversion is there, now this right side comes here, means now the slope line will be like this, ramp will be in this fashion. So when ramp is in this fashion it will has negative slope because you have replaced t by minus t, time inversion means. So that is the reason you are going to have slope inversion. Positive slope in RHS will change to negative slope in LHS, or positive slope in LHS will change to negative slope in RHS. So time inversion, positive slope to negative slope change will be present. Now see, method 2, x of 1 minus 2t you can write as x of minus 2t plus 1. So now again we are following right to left, t by t plus 1, that is time shifting. Rename it as another signal, say y of t, that is shift left by 1 unit. Next you are replacing t by minus 2t, time scaling of minus 2 means time scaling by 2 plus time inversion. That is you flip the signal with respect to y axis. This entire portion draw right side, this entire portion draw left side. Apart from that you need to do the scaling by 2. So first we performed scaling by minus 2 directly here. So if you see the next step, the flipping is done. You can do in this fashion directly, or you can first divide it by 2 and to the resultant signal you can flip. Instead of dividing by minus 1, directly you flip and draw. Interchange LHS and RHS part with respect to y of t or y axis and draw. This is the third method. which is left to right. First we do time scaling and inversion, next time shifting. Observe it carefully as it is self-explanatory. If time shifting is performed after time inversion, the nature of shift must change from advance to delay. So a lot of complexities are involved, hence I am not explaining this method because it will, even a confident student might feel little confusion. So prefer and learn other two above methods and leave this left to right method. Well, guarantee you should leave whenever time inversion is also involved. Construct waveform for the following functions from x of n. So x of n is given. If you see, its sample value is sample amplitude value is 1 at index n equal to -2. Sample amplitude is 2 at index n is equal to -1. Like that, he is asking you minus 0.5 into x of 3 minus 2n. So first, we minus 0.5 means this is the amplitude scaling, means amplitude scaling by 0.5 and amplitude inversion. Directly each sample value can multiply by minus 0.5. This is completed. This is what is important. So earlier amplitude, each sample value multiply with minus 0.5. There is no confusion in that. But to find x of 3 minus 2n, you need to follow any one method. Here mathematical approach is used. He has written the sample amplitude values and the time occurrences of this. Now you replace n by 3 minus 2n. So here earlier 4 by 3 t is there in the amplitudes column. We replaced t by new value in the amplitude column. But here none of the sample amplitude values are dependent on the time index n. Only the time indices are dependent on n. So replace n the time column by 3 minus 2n. So 3 minus 2n is equal to minus 2 means n is plus 2.5. But I already told you in the discrete time case, n is always a integer only, positive or negative, but not a fractional part. Integer only, always. Why? Because it is a discrete time axis. Discretized time axis is discretized. Discrete integer values only valid. At n is equal to plus 2.5, signal value is undefined. It is not 0, it is not some value, it is not 1. It is undefined, not defined, no definition. Nobody knows. Mathematically, we cannot define its value. It is not infinite, it is undefined. There is a lot of difference between infinite and undefined. Infinite is also a value, very large value. But undefined is you cannot define the value only. N is equal to plus 2. You are going to valid, you are going to get 3 minus n equal to 0, sample amplitude value is 2, means 3 minus 2 n equal to 0, n is equal to plus 1.5, it is undefined. Like that you do. Now we are going to get only effectively 3 sample values. So that is, information is lost because of decimation, doing first. No, second question, x of n minus n plus minus 1 whole power into x of n. This is x of n. Now he is asking x of minus n means either each of these indices value multiply with minus 1. That is one approach. Instead of that, as a shortcut, whatever is there in the RHS of x of n axis, RHS of this vertical axis, of this y axis, draw left side, this you draw right side. In other words, same you draw here, same you draw here. Now minus 1 whole power into x of n means this is the scaling factor. Now this is the first time where a sample amplitude value or the amplitude of x of n is dependent on time index n. So for different values you get different values of amplitude. Now you multiply those corresponding these set of values with the x of n sample amplitude values and get them. Now do a plus b to get the final answer. Addition, subtraction and multiplication of two or more discrete time signals are performed between their amplitude at any particular instant of time. Say this is one instant of time. As it is a discrete time signal, there are discrete instants of time independently. So at each instant of time, you perform the addition, multiplication, subtraction operation individually for each of the samples. Next class, we will see the basic signals.